Well, good morning, good afternoon, good evening, everyone. I do see some folks on here that I recognize names for that are in Europe as well. So we're going to walk through a training session today on how to implement security in D2iQ Konvoy. And we'll have a little bit of an overview on Konvoy if you're not familiar with it. And we'll actually have a live demo. And after the session today, you should be able to take everything you've seen and have access to the software and the manifests and all the files that we use to actually implement this on your own. So I'm going to kick it off with just a couple of slides, and then Deepak will also have a couple of slides, and we're going to just dive right into a demo. And the first thing I want to talk about is really the change in security. And so, why is it that we're actually having a session today on network security for Konvoy? And over the last 8 to 10 years or so, I'd say many of these developers have started to move from more of the monolithic applications and your Java applications and EJBs, everything that's going on there. And they've started to re-architect towards microservices. And this trend has been going on for quite a while. And but the microservices, what's different about them is while the monolithic applications primarily used in-memory function calls, there may be just one or two different connections to other systems like databases, et cetera. Now what's happened is that the application itself, instead of in-memory function calls, is actually using the network as its communication fabric. And so network becomes a big consideration in general for these applications. And the traditional applications from the past had actually used typically a perimeter firewall, which is the dotted circle that we have around here. And that tended to keep the bad guys out because there's really one thing to come attack, which was your application. But now that we've broken these into lots of tiny little applications and communicating over the network, what's happened is that the perimeter has actually moved from one kind of massive perimeter around the application to micro perimeters that you have to put around your microservices. And that's driving quite a bit of change because the microservices, they act quite a bit different from the monolithic applications that security teams are used to using their traditional network security tools to manage. And so, policy enforcement now has to move from what used to be a firewall to something which is more like a micro firewall around each one of your microservices. And this is something that's built in out of the box with Konvoy, and we'll talk a little bit about that today. Deepak?
Yeah, thanks, Andy. So just like Andy said that today's way of deploying application is more towards microservices. But with microservices, the de facto platform that comes into mind is Kubernetes, right? And then Kubernetes is an orchestration manager, sort of, that orchestrates basically containers. And I'm assuming that this group is aware of what containers are, so not going into that detail. But the point that I want to bring home with this slide is your application, when it runs in a Kubernetes environment, it's just not the decision about the application, it's also the ecosystem that you have to now decide. For instance, Andy touched about the network firewall or network policy that you have to now think about. You also have to think about how do you access those servers from an external client, like what should be your ingress, and what should be your logging stack, what should be your metric stack, and things like that. Things or application that comes in place when you start doing basically day two operation, which is backup, logging, metrics, tracing. And so the slide that you see in front of you is like a bunch of applications that pretty much doing the same thing, are categorized together, are grouped together. And now as an end user, you would have to, if you're constructing everything on your own, like if you're bringing your own Kubernetes cluster, you also have to make decision about which applications to use for operation. And so, Andy, next slide, or maybe I think there's an animation to this slide. So there's a decision that has to be made on the cloud provider. There's a decision that has to be made, like what container runtime you have to use. Keep going, Andy. As I said, monitoring stack, logging stack, ingress service mesh. So basically, all these decisions where basically you have to select what application you want to use, because there are multiple choices. So now what Konvoy has done is basically solve this dilemma of what day two operation application you need to choose. And if we have picked it, the ones that are best in the industry for our customer. So basically Konvoy is a combination of vanilla Kubernetes cluster along with the day two operation, day two applications that you would need to have a production ready cluster. And so if you can see on the right hand side, there are a bunch of applications that helps you in logging out of the box, monitoring, disaster recovery, which is like a backup and recovery. Then there's a core DNS, which is now integral part of Kubernetes itself. There's a load balancer, which in cloud provider case, it's a cloud provider load balancer, but for on-prem, that's a decision that you have to make. In Konvoy case, it is MatlLB for storage and service mesh. And if you see in the center, that becomes the core of Kubernetes is something which is networking, for which Konvoy heavily depends on Calico. Like without Calico, it wouldn't have been possible to have a Konvoy sort of an application. And the next slide. And so if you see, typically to deploy a working production ready cluster, there are stages in which different application comes into play and how they collectively gives you an environment to run your own workloads, starting with Terraform, which helps in infrastructure automation. Then Kubernetes, as we know of, is container orchestration system, networking, storage, DNS, and then bunch of applications that helps you in day two operation. And so Konvoy is what you get all these applications selected, pre-selected, and pre-deployed for you. And we'll see some of that once we go to the demo stage. Andy, back to you.
All right. So the area of day two operations we're going to talk about today is security. And so Calico is providing two different capabilities. The first is the networking, and Calico is the best CNI that's out there. It can integrate with your on-prem network quite well. So if you need to do things like BGP peering with top-of-rack switches and a variety of different use cases that really integrate your cluster with the enterprise, we work very, very well at the network layer. You can use our CNI and cloud providers as well. Many of the cloud providers actually do use their own networking, but what's differentiated on the clouds and across all environments is Calico has what's called network policy. And the network policy is Kubernetes' way of securing your environment on the network layer, which is something that's, as I said earlier, something that's very critical to think about, as that perimeter firewall has really moved from one application to dozens or hundreds of applications. Calico is a safe bet. The reason why I say that is all these different providers that you can see up here, this is pretty much most of Kubernetes land that you would think of, all have evaluated multiple different vendors and have all arrived and selected Calico. So through our partners, at least, we know that there are over 150,000 Calico clusters that are running out there today. And we know that there's a lot more than that are really running that we don't know about. But Calico is definitely a sure bet if you're looking at how do I implement network security in my cluster. And it's free open source software. The team at Calico is really backed by a company called Tigera. So Tigera had actually created and invented the project And we have over 100 maintainers, but we're the primary maintainer of the project. We also have contributed upstream into Kubernetes with their network security constructs for network policy. We've also contributed to Istio. We were one of the launching partners there, and a lot of contribution as well to Envoy, specifically around a lot of the authorization and authentication protocols that they use there. So, the punchline here is that it's not that we integrate with all these environments, it's that all of these companies, all these distributions have actually decided on their own to integrate and embed Calico into their platforms. And D2iQ, focusing on day two operations, provides not only Calico, but quite a bit of additional functionality, but we're going to focus on Calico today. So I'm going to talk a little bit about network policy as an introduction. And I see some of the names on the line today have been to prior sessions before, so this is going to be a little bit of a recap on what you've seen before. But so traditionally, firewalls are really based on an IP address. And this is the way that your network security team thinks about securing the enterprise. And not only do they think about it that way, but it's actually internal compliance and sometimes external compliance that drives that. A lot of the compliance initiatives that are out there, like your PCI DSS and others, they really haven't been updated to address what happens with a cloud native environment. So the challenge with using a firewall and trying to monitor and protect dynamic traffic is that a container can spin up, can spin down. Kubernetes basically takes care of this for you. You always make sure that there's enough workloads that are running, but you can't tell what host they're going to run on. You can't tell what the IP address will be. And in fact, there's this high churn related to that. And obviously, the firewall model breaks down with that. And so using network policy, this is really Kubernetes' native way of addressing these challenges. And so rather than using an IP address, what we do with network policy, which is a native Kubernetes construct, is to really focus it more on the labels. And Kubernetes network policy really focuses on the labels on the pods. And I'll talk a little bit about how Calico policy is different from that or extends on that. But what we do is we use key value pairs instead of IP addresses to monitor and control traffic. The other thing is that everything that you do in Kubernetes is declarative. You tell Kubernetes, and this is the way that it's been invented, this is the reason why it's there, is you just say, Kubernetes, just make this happen. I want 5 copies of this service running at any point in time, and it makes it happen. You don't really have to think about the underlying details. And in this case, that's how security works as well. And this is a very natural way for a Kubernetes operator to manage security is in a declarative format. Declarative formats can also be stored as code, and that's like a huge advantage to automating the releases of what you would expect to be within a microservices environment, much more rapid releases. And Kubernetes network policy is dynamic, meaning that as you have these workloads that churn, you might need to scale out, so you have additional workloads. You might need to scale back. You might have workloads that fail. You might have a node that fails, and workloads get moved to another node. It's a very dynamic environment, but Kubernetes network policy has been invented from the get-go to actually handle this in the same way that a firewall would, but in a much more dynamic manner. And this is what Calico is all about. Well, Calico provides unbelievable networking capabilities. There are a lot of other networking providers out there. We are really differentiated in our capability of securing that network traffic and ensuring that you're able to meet the compliance requirements that you're going to meet as soon as you start to hit production in day 2 operations. So I'm going to provide a little bit of positioning for folks today because the most common kind of pattern or anti-pattern or what you want to call that we see is that these teams who are launching Kubernetes applications, whether it be an application team who does this on their own or whether it's an internal IT team, who's creating a platform for folks, what typically happens is you near production, suddenly that's when all these other teams, typically your networking team, your storage team, your security teams, compliance, others, suddenly that's when you hit their radar. And I'd always advocate to go position Kubernetes in your project to these teams before you have to run into the issue of them, really kind of struggling to understand and digging in and figuring out how you're going to get to production, because that tends to slow things down. So the way that I suggest positioning Kubernetes and network security is as a zero trust network. And the reason why we do this is that Kubernetes and network policy truly is a zero trust network, first of all. But second of all, this is a much stronger security stance than what anybody's ever had with their typical perimeter firewalls they've used in the past. This is also something that the security people, this is a major trend in the security industry. And zero trust is something which is kind of this idealistic thing that people have on their roadmap they want to do. We're seeing more budget allocated to it as well. But you want to position Kubernetes as not this thing that's really hard to secure and how we're going to fit into our model, but something which is even more secure than what we're doing today, and also the direction that you're likely looking to go. And so let me tell you about why we're zero trust network security. The first is that the network securities policies are declarative. And so the important part here is that once you implement a network policy within your cluster, it closes your cluster, meaning that if there's a policy that's applied to a particular pod, that pod will not accept any incoming traffic that hasn't been declared. And what that does is, with the security land, they call this least privileges, meaning you're basically whitelisting traffic that's allowed to communicate with that particular microservice. And as soon as you apply a policy, that kicks in. And so we talk about least privileges. The second is that this is dynamic. And so the identity typically used to be an IP address, and we're able to tell the security team that IP addresses don't work anymore, which creates a big challenge. But we do have multiple forms of identity that we can actually extract from the environment. So we look at the network identity that as reported by Kubernetes, but we can also look at other forms of identity as well, including like X509 certificates that would basically form as like a multi-factor authentication, not for your end users, but from service for service communication. And this is another element of zero trust. So the word zero trust, the phrase, really means that you don't trust anything on the network or your applications. It means that at all times that you assume that a network's been compromised, the application's been compromised, or the infrastructure or even Kubernetes has been compromised. And so, your response to that is a defense in depth. So the security policies are evaluated not just at the workload, but also other multiple points within the stack, including the edge of the workload itself, the Kubernetes, and at the pod level, as well as at the infrastructure level on the host. So this enables an application that might have been compromised in some way to not be able to compromise the rest of the environment, because the policies are also evaluated at these other layers of the stack. So it reduces the risk. The other thing is that, with Calico, most people are familiar with layer 3 rules, basically the TCP traffic that's flowing around. But we also support up to layer 7 rules as well. So if you have a service mesh that you're using today, we can actually sit on top of that service mesh and use one single policy language to drive the entire service mesh as well as the layer 3 traffic. And so you've got your HTTP traffic for your microservices are communicating with each other, but you also have that layer 3 traffic for things like connections that are going out to databases. So, this is really the way to position, and we found that this really works well with trying to get through that particular stage gate of the network security team. We're able to provide more of a zero trust type environment. So just a little bit about network policy, and I'll show you a little bit about Calico policy, and then we'll get into a demo here. But network policy is all implemented as YAMLs, which is really everything else that's in Kubernetes as well. And what we have here is an example is really an application that has 3 different workloads. There's and each of the workloads has a label on it. So this would be your pod labels. We have a pod label called role, and we have front end, DB, and helper. So if we create a network policy, and this is using just the standard Kubernetes network policy, what we do is we define the namespace that it's in, and then we have pod selectors. And so what this is doing is it's saying for any pod with role equals DB, which would be this one, what we're going to do is we're going to allow ingress from, and we can put a selector here for role equals front end. And we're going to do that over port 6379 TCP traffic. And suddenly what will happen is this workload will enable this traffic. But once a policy has been applied, it's actually going to reject all other traffic. And so if this role equals helper is trying to connect, the connection will be denied at that point. And so this is an example of Kubernetes network policy. Now, Calico does Kubernetes network policy. And if you want to use just the standard Kubernetes network policy, we will implement that. We will enforce that traffic, but we add more with Calico policy. And a couple of the important things that we can do, first of all, is an order. And that's the order in which the network traffic is evaluated. And what the order allows you to do is you can implement a higher level policy. Let's say a policy such as development should not talk to production. And you could implement that policy. You could give it an order number that has higher precedence priority than any other policies, and that will reject the traffic before it even gets evaluated by any of the microservices. And generally, to enforce this, you'd use some kind of an admission controller to make sure that people don't that are checking in their that are deploying pods are not checking in a network policy that has an order level that's a higher precedence of what you want to do. So we see many organizations that are focused purely on the open source front using these admission controllers to do that, to make sure that more of the corporate global policies are being implemented. We can also, one of the other things which is to highlight here is service accounts. So in Kubernetes, there is no RBAC around pod labels. And so developers can kind of put whatever labels that they want, but the Calico policy doesn't just work on pods, it also works on service accounts, and service accounts are RBAC'd. And so what you're able to do is actually apply the labels that would control traffic to the service accounts. And the other big one is the selectors. And so the selectors are pretty rudimentary with the basic Kubernetes network policy. We've extended that to make the more Boolean logic that you can use to select your pods and your service accounts to control using Calico policy. So that's really how we've added that. There's also additional protocols, and you can define custom protocols as well. And that's all related to the powerful networking that Calico provides. Finally, the other thing is that we have this capability of doing layer 7 as well. And so typically the application teams, they care a little bit less about some of the layer 3 rules and how the cluster is segmented and which namespaces are allowed to talk to each other. That's not really what they care about. They care about, I've got a microservice called table, and it's got some kind of an ID related to it, and there's this customers, and I want to be able to have this service post, so that's the web method, to this particular path. And so this gets you kind of up to the level of where the developers would work in the way that they think. And these policies from layer 3 through layer 7 can actually be combined in this way. And all of this is really leading into more of a policy as code model as well. And so this is where this trend of DevSecOps intersects quite well, is that what we can do is we can actually, without going to some firewall team and saying, hey, create punch a hole through this port to this IP through the firewall and waiting for a change ticket and going through the 2 to 4 weeks that it takes to get that done. What you can do now is you can actually just put these policies as code into your Git repository, and you can fully automate this whole process. So there is no manual invention to introduce strong network policy that aligns with the corporate requirements. And the final thing that I was just going to show here is that with the defense in depth, just as an example, there's a micro firewall that's really in front of each pod, and we're managing that. But we also have the micro firewall at the host layer as well. And even for this pod-to-pod traffic that would occur from pod A to pod B within one node, it's still going to go through the actual host as well. And so there's multiple layers of protection that we have available here. And this is a little bit of an eye chart, but and I'll send out the slides to everybody after this, but the focus here, and really the punchline, is that it's really unnatural to try to take firewalls and traditional approaches to security and apply it to a Kubernetes environment. It just plain doesn't work. It's not right. And it creates things like downtime and whatnot with applications. It really slows the deployments. And so Calico Calico on Konvoy is a very cloud native approach to doing this. And it does require a little bit of positioning with your security teams. And so I do always suggest that you kind of educate them as much as you can ahead of time. But, it's the way to go. And I mentioned this a couple times, but Calico and Calico policy is part of Konvoy. So if you're using Konvoy, you want to stay industry standard. I don't want to use, something specific to Calico and their selectors. Calico is still embedded in there, and it will do the kind of the native way of doing it in Kubernetes. We also can add to that. And if you go up to the documentation on D2iQ, and there's a free trial that we'll talk about as well for Konvoy, you can find right under here under the networking, there's a lot of information about Calico that's available right there. So we're going to dive into a demo here, and Deepak is going to go ahead and lead this. Deepak, just let me know how you want me to flow through the slides, and just tell me next.
Sure. Thanks, Andy. So the sort of services that we are using today to demo is what you are seeing on the slide. So there are 3 parts to it. One is, if you move from left to right, it's client application. You can imagine an application that is running and sort of mimicking an external client. Basically, this is the application that is facing the internet. And then there is second part, which is front end or back end, which is the core piece of the application where the actual business logic lies. So mimicking a typical application which has a front end, which is a sort of UI that interacts with the client and has the state stored in a backend database sort of a thing. And then just to help us visualize, there is a management UI, which basically, and you will see how we are using management UI, basically probes each of these applications and gives backend status whether these applications are first running, and secondly, are they able to communicate with each other, which is what we will demonstrate by network policy when we go deeper in the demo. Andy, next slide. And so what we want to demonstrate today is, if for some reason, let's say client application get compromised or attacked, our network policy could still protect our main application, or within the main application, basically the data piece. And we will show how that even if the client is compromised, by clearly defining the network policy, we won't allow an attacker to be able to access the backend database.
Yeah, actually, so let's.
So
what I'm going to do is I'm going to hop out and let you share your screen now.
Yeah.
Make sure that you are here as. I'll make you the host, so that should allow it.
Right. Can you see my screen?
It's just starting. Yeah, we can see your screen.
All right. So the sort of flow that I will be using and the policy that we will be using are on this slide of Calico, and it's accessible. We'll share the link later in the demo, but this is the link. And so as a first step, what I'll be doing is I'll be deploying the application. And when I say deploying, actually deploying the front end, back end, client, and the management UI. So let me quickly show these YAML with you. I have downloaded them, but they're pretty much the same as what you see on the side. So hold on, let me take this bar down. Yeah. So there are a bunch of YAMLs. Just to start with, the first one would be the namespace one, which is pretty straightforward. It creates a namespace star, and star will be the namespace where we will be deploying our actual application. Then there is an application, let's start with management UI, which is 01. And if you see, it's creating its own namespace called management UI. Then the service, it's a typical Kubernetes construct. And then the replica controller, which basically deploys this application Calico star collect. It's a probing application that probes all the other application to make sure that they basically it gives a feedback status of which application is able to connect to which other, which will come in handy in our demo. Similarly, there are other backend. So the backend application is mainly it is Calico star probe. And what it does is it takes a list of URL and it starts sending the probes to these URLs that we have provided to this application. In this case, literally, it's the backend application is sending the probe to front-end application in the star network, the backend, and the client. Similarly, the others, front-end and client, are exactly same as backend. It's just that the URL that they take is sort of indicate what application it is. So let me quickly launch this. And today, as we said, we are using the Konvoy cluster. In our earlier slide, I was saying that the Konvoy comes with its own set of applications that are necessary for the day 2 operation. So just to give you a glimpse of that, a list of all the pods that are running in the cluster, sort of showing that it has all the day 2 application already running for you when you deploy Konvoy. So it has Prometheus for Metris, FluentBit for logging along with the Elasticsearch. Then these are typically, it comes with vanilla Kubernetes, the proxy, the controller, the API server. Then it has the storage one, Core DNS, Calico. The main part of today's demo is for the networking and network policies. Cert Manager for certificates. So now I'll be using this cluster, this Kubernetes cluster, to deploy. Let me go back to the UI. I'll be just copying the YAMLs from here, which is what we just saw. So first it is creating the namespace. Then the management UI application in the management UI namespace. Backend application, front end, client. All right, so all the applications are up. So I'll be using port forward just to access this application on the UI locally. So this port forwarding I'm doing for the management UI, which will give us the nice UI. So, all right. So let's take a look. So the thing that you see in front of us is coming from the management UI, and the way it is constructing this graph, each of these circles are the application that it found in the probing, and then the lines that you see is how this application connects to the other application. So for now, because we don't have any Calico policy, each of these applications are able to make a connection with any other application. So front end is making a connection to backend and client, and similarly other two. Now let's deploy a first policy, which is basically deny all communication. So by default, deny all, which are these two YAML files. I'll show you what they are, but let me just issue the deny. Meanwhile, we can see what these YAMLs are. Okay, so if I do default deny, which is basically selecting everything, when the pod selector is, the mesh label is sort of empty braces, then it selects all the pod labels. So basically it's saying don't allow any communication between any two applications. So let's see what's the effect of this denial on our, let me refresh it. So blanks, basically management UI itself is not able to make connections to any of the applications. So it's showing blank. Now let's allow management UI at least to make connections to the application. So we'll open it up, the UI, to make connections to the application so that we can at least see the application. And let me quickly show what this allow UI. So as you can see, allow UI basically selects all the pods, but then it allows the ingress operation if it is coming from a name selector which has a match label as management UI, this role on that name selector. So this is basically saying, literally saying that allow, if I am a front end application, this allow UI allowing the traffic coming from the management UI. So let's see what is the impact of this. It will basically now show that at least management UI is able to reach to all other applications, but these applications are not able to reach to each other. So it's like, because you see these grayed out, that means they are not able to make connections. So now let's allow the connections that we actually want for our application, which is front end is able to make connection to back end. That's definitely we want to do. So let's allow that. So if you see this backend policy, it's for the, so this policy is defined for the backend application. And then the backend application, the ingress rule is allow something that is from the front end. And it's the nature of, basically you can also classify, now the front end is not allowed like for all the communication, it is only allowed for the TCP with port 6379. So now if you see on the UI, the front end application will be able to make connection to the backend application. Right? So this communication is allowed. Now what we also want is client to be able to make a connection to front end. So let's allow that one. And if you see this front end policy, it would be pretty much same, but for the front end application. So it's a front end policy for front end application, which is allowing client on port 80, and the nature of the traffic should be TCP. Right? So now client is able to make a connection to front end, and front end is able to make a connection to back end. This is what we wanted. And we don't want client to make a direct connections to the back end. That's what network policy is allowing us to do. But in the absence of these network policies, basically all communications were allowed. That's about it for demo. Andy, you want to go to slide again?
All right. So let's pop back in here. Okay. So what we've been able to show is that this scenario where the client application gets popped through the perimeter firewall is still protected from accessing the backend application and the data. And just a couple of takeaways on this is that the way that Kubernetes implements network security is quite different from other applications and other workloads and the way that that's worked in the past. And it's network policy that's used. Today, it's currently the only way that's really effective to do network policy, to do network security. Calico is just one network policy engine. There are others that you can use out there, but Calico is pretty much the industry standard today. It's embedded inside of every platform that you would plan to use. So you might start out experimenting in something like an EKS and decide that you want to deploy back on-prem or self-manage using Konvoy. Your network policies are going to work across any environment that you decide to use if you're using Calico. And Calico is a superset of Kubernetes network policy that adds a lot of flexibility that's typically going to be required as you become a lot more kind of advanced, you have more workloads that are running. Kubernetes network policy is a little bit more brittle, and Calico is something you can trust to be there anywhere you go.
So yeah, anybody who wants to try, there's a free trial for 90 days, which gives you complete Calico access to complete Konvoy, and you can play with it, see what all comes with it. There's a link for documentation, extra documentation if you want to know more about Konvoy. And the slides will be shared right later.
Yes, these will be shared. Yeah, so get a free trial for 90 days. This will get you up and running a little bit faster than, kind of roll on your own. You're going to get all the day two kind of best of breed built in to your Kubernetes distribution by choosing Konvoy. And it's a quite generous trial for 90 days. And, if policy is something that's important to you, and if you're looking to actually implement network security, if you need to get to production, Calico will help you there. And there's no problem there. You can go fully open source. We also do offer what we call Calico Enterprise, which is, if you like Calico, you're going to love Calico Enterprise. It's Calico on steroids. It provides a GUI that you can log into to create policies. It will, especially if you have a brownfield environment that already has workloads running in it, it will monitor the traffic and help you auto-generate policies to allow that traffic, but to kind of lock down your cluster. We provide troubleshooting tools. One of the hardest things to troubleshoot within Kubernetes is network connectivity. Like, why can't my services talk to each other? Why are they timing out? And we provide powerful tools that help you with that. There's also some extensions to network policy that we do. So a lot of what we talked about today were all these services that are inside of the cluster, but it tends to be that egress is actually a really big problem for Kubernetes clusters. So how do you have, for example, a service that's running in Kubernetes that needs to connect out to some database which is behind a firewall, and you don't really have a predictable IP address? Like, you might be able to define a few routable IP addresses, but those are also a limited supply. And so, Calico provides this ability to connect to things that are outside of your cluster. Now, and if you're deployed up to AWS, this might be your RDS databases, your Elastic Cache, and integrating with the service groups there. And there's security groups there. On-prem, this tends to be more around firewalls and how do you get through those. And finally, while Calico itself will implement and will enforce what you need to comply with security controls and compliance, it's very difficult to report on and to go back and to prove that you are compliant. And so Calico Enterprise makes that really, really easy with just one-click reports that you can send to an auditor, and it provides all the information that they need. Free trial is available for Calico Enterprise as well. You just hit tigera.io/trial and give it a try. So that concludes what we have for today. I'll go ahead and open it up for any questions.
So thanks for the demo. This is Srinivas. So quick question on this enterprise thing you have, right? So does it mean the enterprise product you have only supports this policy automation and more of a security thing, or does it also provides us the way to build Kubernetes clusters and scale them and end-to-end setup of Kubernetes?
So D2iQ is more around day two operations as a whole. So if you're thinking about scaling your Kubernetes deployment and running in a production environment, D2iQ provides kind of a full end-to-end, out-of-the-box suite of open source products that are all kind of bound together to help you do exactly that. Calico Enterprise is it provides many additional capabilities. So while we do some of the different bullet points that I talked about here, which are all related to network policy, we also provide some pretty advanced security features as well. Like we can detect anomalies, things like domain generation algorithms are being run, and we can ingest threat feeds. We can protect traffic coming in and out of embargoed countries. There's a lot more with compliance that you can do with Calico Enterprise. So what I'd say is that if you're planning to move to production, Konvoy is a great way to have all the tools that you need for the day two operations. When you run into the problem of the network security team and their requirements, or potentially, depending on the application, compliance requirements, that's generally when most people look to Calico Enterprise.
I see. So both are isolated, like each has its own accounting and.
Yeah. So Convoy is a Kubernetes distribution, and the containers that we'll have are a lot of the services that they have for operationalizing Kubernetes. And then Calico will also run, regardless of whether you run just Calico open source or if you run our enterprise, it's deployed as a daemon set. So you get one pod that's running on each one of your nodes, your hosts, and that will protect both the node and all your Kubernetes pods. But Calico also does host protection as well. So it could be that you decide that you want to actually use this to run microsegmentation across your AWS instances. You can do that with Calico as well.